Okay, so can you guys see my screen now?
Sir.
All right, so is my voice clear so far? Is it loud enough? Okay, great. All right, so uh, I have to apologize. I just remember 5 minutes ago that I wasn't able to publish your quiz number one. Okay, so your module one quiz supposedly was due today, but I did adjust the due date until tomorrow. Okay, so today is already June 29, so I adjusted the due date until tomorrow so that you guys can have or you can take this one today or tomorrow. Okay, so including the module 2 quiz. So you have two quiz, which is due date tomorrow. Okay, so yeah, just answer that quiz before tomorrow. Okay, or before it will be due. Okay, and for your third quiz, so the due date of this one is July 2. So you guys have 3 more days. Yeah, 3 more days before the due date of this one. All right, and for the last week, so week number 3, so we're going to talk about module 4, actually module 4 only. And then for the module 5 and 6, this is actually already let's say 80% of the module 5 you guys already know this one. So we will not meet for the module 5 anymore. I'll give this one to you guys as your self-study module. Okay, the same with the module 6, though I'm pretty sure that 50% of this one you might be already familiar with. But the thing in here is you have to learn this one by yourself. Okay, so from the basics up to the end. So you're the one who's going to learn this one because one of your laboratory is about Microsoft Excel. Okay, so you're the ones going to explore your own Microsoft Excel. So it could be 2016, 2015, 2018, 2019. So any version will do. So I think even though your versions are different, so this one will still be fine. Okay, the algorithms, the way how to do it is still the same. Okay, so that Microsoft Excel is, I think, this lab number 6. Okay, so this is already your final laboratory, lab number 6. So the due date of this one is, okay, so oops, here. So the due dates of the lab number 5, lab number 6, module 4 quiz, and then module 5 quiz, okay, and then including the case study number 4 will be on July 10. Okay, so you guys have one more week, like 11 days before the due dates of those given activities. Okay, so yeah, then after that, your midterm exam already. Okay, so your midterm exam will be on this coming 15, 15, 10, 12, and then 13. So 10 is Saturday, and then 12 is Monday, and then 13 is Tuesday. So if we can finish everything as early as we can, let's say most of you are already done with the activities, then maybe we can have your midterm exam on this coming July 10th. Okay, so the earlier the better, I guess, so that just in case there are others who won't be able to take the midterm exam, then they still have the chance to take it on this coming Tuesday, okay, July 13th. Okay, so are we clear so far with that? Hello, hello. So if you guys haven't eat your breakfast yet, so feel free to eat it now. So you can eat while listening. You can drink your coffee while listening, so it's a lot better. All right, so yeah, we're almost done. So we are now on week 3 actually. Okay, even though we are still at week 2. Okay. All right, so that's only it for my additional announcement. So if you guys don't have a question anymore, then uh, we can start now. So the topic for today is Module 4 number systems. So in here, we're going to talk about the types. of number system. So as you guys can see, we have five. The first one is decimal, second one is binary, third one is octal, hexadecimal, and then n-based system. So maybe you are already hearing about binary. Maybe some of you are already heard about decimal, okay? Or maybe heard of you already octal, hexadecimal. So in here, we're going to talk about them one by one, okay? And n-based system. So later on, I'll discuss what is this n-based system. Then after that, we'll discuss number conversion and operations, side numbers, and then computer codes. Okay. All right. So without a further delay, let's now start with digital circuits. So when we see digital circuits, it is binary in nature, but several types of representations of numerical data are in use. Okay. So when we see binary, it's actually 0 and 1 only. But sometimes it's not only 0 and 1, okay? Because we have other types of representations. Like, for example, an octal can contain a number of 0 to 7. A hexadecimal can contain a number 0 to 9, and then at the same time a letter A to F. Okay, so later on we'll discuss more about that. But here are the types of representation of unsigned integer number. Okay, so when we see unsigned, it's just simply a positive number. Okay, so if it's signed, then it is a representation of negative number. So we can have a positive binary or a negative binary. So we can have a positive octal or a negative octal. So the same with decimal or hexadecimal. But mostly, 80% all the time, we're always using unsigned integer. Okay, we don't use uh, sign number. Okay. All right. So let's start with decimal. So decimal number systems. So people use decimal representation to count. Okay. The one that you guys can see on your hand right now. So digit is derived from the Latin word for finger. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fingers. So since we have 10 fingers, so it uses 10 as a base. So it's very obvious. Okay, just look how many fingers you have. Well, unless you have an extra one, or you have, you're lacking one piece of your finger. So it's a different scenario already. But the default one is 10. Okay, so it is also called base 10 system. Okay, but take note, even though this one is a base 10, okay, it doesn't end up with 10. Okay, why? Because in computer, okay, we always start with 0. Okay, we count starting from 0 and then incrementing. Okay, depending on what number it will end to. So in here, if we have the base 10, so it's 0 to 9. Okay, not 1 to 10. Just take note on that one. Okay. And next one is binary number system. So basically, when we see binary, again, just like what I mentioned a while ago, it's just a representation of 0 and 1. Okay, so there are no other combinations numbers when we see binary. It's just 0 and 1. There is no way that you will have 2, 3, 4, 5, 6, 7, 8, 9. Okay, there is only 0 and 1 in binary. Okay, so that is one thing that you might want to memorize, or you might want to remember when it comes to binary number system. Okay, so basically if it's 0, then it's just off, and if it's 1, then it's on or turn on, or in other words, we call this one uh, inactive, okay, or not active, and then 1 is active or it's activated. Okay, so yeah, that's basically the meaning of 0 and 1 in our binary. But before that, okay, let's start with one character only. So lowest, okay, we call that 1 bit. Okay, so this is already the lowest representation of a number in a computer. So the one character that you guys are seeing right here is called a bit. So if we have 2 characters, then we call that one 2 bits. If we have 3 characters, then we call that one 3 bits. If we have 4 characters, then we call that one now 4 bits. And at the same time, we call that one nibble. Okay, so this might be new to you guys, but 4 bit is equal to 1 nibble. Okay, and then having 2 nibbles, okay, or 8 bits is already 1 byte. So maybe this is now the one that you are always hearing, especially right now, like, started with bit, and then nibble, and then byte, and then kilobyte. and then megabyte, and then terabyte, and then petabyte, and so on and so forth. Okay, so as of now, we only have petabyte, I guess. I'm not sure if there is already a larger size of that one, but mostly we only have terabyte nowadays. Okay, even megabyte maybe when it comes to phones storage, like 64 gigabyte, 128 gigabyte, 256. Okay, up to maybe 512 as a internal storage. So external storage is already a different scenario. So you can have up to 1 terabyte, I guess. Well, that's already super large when it comes to smartphones. Anyway, so after byte, okay, so having 2 bytes, which is equal to 16-bit, we call that one word. Okay, so this might be super new to you guys. Like, word? Is it literal meaning of word? So no, in computer we have this kind of size also. We call that one word, but we don't usually uh, say this one or use this one when it comes to storage capacity. We always stick with byte, kilobyte, and then megabyte. But yeah, just to let you know, so we also have this one. So 2 bytes is one word, and then 4 bytes is double word, or this one is equal to 32-bit. Okay, so here are the representations. So here is the lowest bit, and then here is the highest bit. Okay, so we have here the 1 byte, which is 8-bit. Okay, and then 2 bytes, which is one word, and then 4 byte, which is one double word. Okay, so are we clear so far? Were you guys able to follow? Hello, hello. So just give me a thumbs up if everything is clear, if everything is good, just to let me know that you're okay with that. Well, if you have a question like you wasn't able to understand one of the things that I'm saying, so feel free to raise your hand or just speak right away. Okay, just to ask that question of yours. Okay, so the nice one right here is the representation of our decimal in going to binary. So again, when we see decimal, okay, so it is 0 to 9 actually in here, but it could exceed up to 15. Okay, but this is not decimal anymore. This number right here is already considered as a hexadecimal. But anyway, uh, it could be still part of decimal since hexadecimal is a variation of a decimal. Okay, so for decimal, we have 0, 0, 0, 0. I guess it's very obvious. Okay, and then as you guys can see, we have 4-bit. Okay, that's the default number when it comes to forming a binary number. So even though we only have 0 and 1, but we still need to have a 4-bit character in binary. Okay, just to represent the decimal in a complete manner. So for the zeros, of course, it's a 0, 0, 0, 0. So I guess it's pretty obvious already. But for 1, we have 0, 0, 0, 1. And then for 2, we have 0, 0, 1, 0. So maybe at this point, you cannot get this one already anymore. So don't you worry. Let me explain this one. Okay, so in binary, okay, so the default count of binary characters is 4. Okay, so all in all, we have 4 characters. Okay, so of course, it is any combination that you can think of as long as it's a 0 and 1. So all of them have their own different values, of course, or different results. So like, for example, 0, 0, 0 right here. This is 1. Oops, ayaw ng tab. I guess it's a lot easier if I'll just use Notepad. Okay, so let's have this 0, 0 right here. Okay, and then in decimal, this one is 0. Okay, and then maybe it's a lot better if decimal is right here. and then the binary combination is on the right side. Okay, and then for 1, it's being represented by 0001. So how did this happen? So if you are going to dissect every character of binary number, so let's say starting from the lowest bit, okay, so this 1 is represented by a number 1. Okay, so the second number, this second 0 right here, this is the second uh, lowest bit. So this one is represented by 2. Okay, the third one is represented by 4. Okay, and then the last one, the highest bit, okay, this one is represented by 8. Okay, so basically we have a pattern right here starting from 1, just keep on doubling. Okay, so the second one is 2, just multiply this one by 2, this one by 2, so 2 times 2 is 4, 2 times 4 is 8, and then if you have more, okay, so let's say you have more binary numbers right here, so you can also do that one. So let's say another 0 right here. Okay, and instead of 8, then this one now is 16. Okay, so there you go. Oops, lagyan ko na ng space dito. Okay, so basically it's just keep on doubling. So 8 times 2 is 16. So if you have more right here, then just double it again. And in here we now have 32. So 16 times 2 is 32. Okay, and so on and so forth. So that's basically it, the representation of binary, or from decimal to binary. Okay, so as you guys can see right here, if you need 1, just activate the number that you need. So 1. If you need 2, then just activate the 2. Okay, so 1, 2, 4, 8. And if you need, let me get this one instead. Okay, so if you need 3, so you have to activate the 2 and 1. So it's 0, 0, 1, 1. So again, this one is represented by 1 and this one is represented by 2. So 2 plus 1 is 3. Okay, so if you need 4, then activate 4 only. So it's being represented by 0, 1, 0, 0. Okay, so this one is represented by 1, 2, and then 4. Okay, so if it's deactivated, then it doesn't count its value. But if that number is activated, then you have to count that value, wherein, let's say this one is equal to 4. And if you need 5, it's being represented by 0, 1, 0, 1. So you need the 4 and the 1. Let's say if you want to activate 8, then it's being represented by 1, 0, 0, 0, since this one is already 8. If you need 9, then just activate this 1 right here. Okay, so 8 plus 1 is equal to 9. So if you need 15, then just activate everything. Okay, so 1 plus 2 is 3, plus 4 is 7, plus 8 is equal to 15. Okay, so did you guys get this one so far? And how did we convert this decimal into binary? Okay, so sir, what if I want to, let's say, have a 16? Okay, then no problem. Just have a 1 right here and then 0, 0, 0, 0. Okay, so this is already equal to 16. So 8 times 2, so this one now has a value of 16. If you want 32, then no problem also. So it's now 1, 0, 0, 0, 0, 0. So notice that I'm, separating the characters every 4. Okay, every 4 characters. So that's just a way, okay, for me to be able to read this one easily. Because if they are something like this, like they are continuously connected with each other, I would be having a hard time, to not let's say see if it's already up to 128 bit, if it's already 256, 512, 1024, and so on and so forth. So with that, you already know that this one is 8, and then this one is 64, and then this one is 128, etc., etc. All right, so that's it for the decimal to binary. And then we also have octal number system. So before in decimal, we have 10 base, right? In octal, it's pretty obvious also, since, from the word octal, we have 8 base or 8 numbering system. However, again, this one doesn't end with 8. Okay, since we are going to start with 0, so this one is being represented from 0 to 7 only. Okay, so to count in octal, the digits combine after reaching a count of 7. So we have 1 to 7, 10 to 17, 20 to 27, 30 to 37, and so on and so forth. So in octal, we don't have 8 and 9. Okay, so that's one thing that you guys need to take note. Once you reach the value of 8, it's already converted to 10. Once you reach the value of 9, it's already converted to 11. Okay, so 9 to 15 in decimal, 11 to 17 in octal. So if we have, let's say 16 right here, it's already 20 in octal, and so on and so forth. So just keep on counting and just keep on skipping the 8 and 9s. Okay, so 0 to 7 from decimal to octal is the same. Okay, however, in octal, again, as I mentioned a while ago, we doesn't have 8 and 9. So in decimal, if we have 8, in octal, it's already 10. Okay, so there is no other explanation for this one, but you just need to memorize that when it comes to octal, we don't have 8 and 9. Okay, so I think that's the easiest way for you to understand how to represent decimal to octal. Okay, well, anyway, so let's have this one. Let's start with decimal first, and then let's have the octal. All right, so in decimal, we don't have a problem with decimal, so we can keep on counting as long as we're going to start with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on and so forth, up to infinity. Okay, that's the default, uh, arrangement, okay, or how we count things in decimal. Okay, but for octal, okay, again, we need to skip 8 and 9. So still the same, how we count things. It's just that we need to skip 8 and 9. So we'll start with 0, 1, 2, 3, 4, 5, 6, 7. And then we don't have 8 and 9. So the next one right here is 10, 11, 12. Okay, let me just align this one. There you go. 11, 12, 13, 14, 15, 16, 17. Again, we don't have 8 and 9, so just skip 18 and 19. We'll jump uh, right to 20 after that. And then followed by 21, 22, 23, 24, and so on and so forth. Okay, this one is also, of course, up to infinity. Okay, so that's basically it when it comes to converting a decimal to octal, or how we count in octal. Okay. So did you guys get the idea so far? Okay, so for now, you don't need to memorize, just at least familiarize or get the logic behind it. Okay, so I cannot explain anything more rather than skipping the number 8 and 9. So that's the only logic that you can get when it comes to octal. Okay, well, anyway, so yeah, that's representation for octal number system. The next one is hexadecimal. Okay, so this one is also under decimal. So if you guys are going to take a look at this one, hexa is a base of 16. But of course, since we always start with 0, so we only have up to 15. Okay, so 0 to 15 when it comes to decimal. However, when it comes to 10, 11, 12, 13, 14, 15, in hexadecimal, it is now being converted into a certain letter. Like, for example, number 10 is already equal to A. 11 is already equal to B. 12 is equal to C. 13 is equal to D, and so on and so forth. So, sir, why do we have to do this one? Why do we have to convert 10 to A? Why can't we just have 10? Well, that's because in computer, our computer reads data every character. So this one won't be read as 10, but this one will be read as 0 and then 1. Okay, so those two are two separate characters. So as a remedy, we need to combine this one, or we need to have a representation wherein this one will be one character only. So that is why maybe this is the algorithm that they come up with, wherein 10 is equal to A. So once our computer uh, got a data which is equal to A, meaning that has a value of 10 in decimal. Okay, and then 11 is B, 12 is C, 13 is D, 14 is E, and then 15 is F. So are we clear so far on how, or why do we have A, B, C, D, E, F when it comes to representation of character in, in binary or in this number system? Hello, hello. Were you guys able to get that one so far? Yes. Um, so the question of Mr. Christopher is, hanggang 15 lang, sir? Well, if we're talking about hexadecimal, then definitely yes. Okay. But of course, you can exceed up to how many numbers you want. But when it comes to hexadecimal, we can have up to maximum of 15. Okay. But you can exceed on that one. That's still under hexadecimal. Okay, of course, that's a different counting again. So 0 to F is 15. And then once you exceed that one, then you're going to go back to 10 to 19, and then 1A to 1B to 1F. So for you to be able to see the difference, okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Just align this one, 8 and 9. So it is the same for 0 to 9 in decimal to hexadecimal. Okay. But for 10 to 15, it's now being represented by a certain character. We're going to start with A, B, C, D, E, and then F. Okay. Then after that, you have to go back to the start, okay, where the number ends. So in here, after 0 to 9, of course, after that is now 10. 10, 11, 12, 13, 14, up to 19. Okay, maybe it would be better if I'll just eliminate this one, and then let's have a number of up to 27, 28, 29, 30, 31, 32. So let's have up to 32. Okay. And then in here we have 14, 15, so it's 10 to 19. So basically you will see the like the arrangement right here. It's only 0 to 9. So in here it's only 10 to 19. 10 to 19, 17, 18, and then 19. Then after that, you have to continue now the letters. But instead of let's say G, H, I, G, and so on and so forth, just add a number right here. Okay, we're in. Of course, we're going to start with 1. So it's now 1A, followed by 1B, followed by 1C, 1D, 1E, and then 1F. Okay, let me just align this one again. All right, 28, 29, 30, 31. There you go. And then after that, of course, after the 1F, then you have to continue this one now. So after 19, it's now followed by 20. So 20 to 29, and then after that, it's now 2A, 2B, 2C, 2D, 2E, 2F, and so on and so forth. Okay, so for the octal, let's continue this one so that we can have a complete representation of decimal going to hexadecimal, and then decimal going to octal. So it's 25, 26, 27, so we don't have 8 and 9. So the next one is 30, 31, 32, 33, 34, 35, 36, 37. We don't have 8 and 9, so it's now 40. So let me just align this one again. There you go. Okay. So are we clear so far regarding with this one? When it comes to decimal to hexadecimal, decimal to octal, or vice versa, octal to decimal, and so on and so forth. So any other questions so far? Okay. Okay. All right. So that's representation from decimal to hexadecimal. So here are the things that we can do. So we can convert binary to decimal, octal to decimal, hexadecimal to decimal, or n base to decimal. Basically any base. Okay, we can convert any base to a decimal. So here's the process. So to convert an integer number in any base to decimal, add all the products of each digit multiplied to its base in increasing power, starting from 0. And to convert a fractional number, so this one is whole number and then this one is fractional or decimal, in any base to decimal, add all the products of each digit, multiply to its base in decreasing power starting from -1. So I know that, if you're going to analyze this one and then understand this one right now, you're going to have a hard time unless you see an example. Okay, so here's the only thing that I could tell you guys when it comes to uh, converting any base decimal. So if it's whole number, then you should have an increasing power starting from 0. And if it's a decimal number, okay, or fractional number, then you should start with -1 and then it's a decreasing power. So -1, -2, -3, and so on and so forth. Okay, so for you to be able to appreciate this one, okay, let me show you guys the format. So we have here the whole number. Okay, so ABC is just any, just a variable. So it could be any number as long as it's a whole number. And then XYZ is representation for the fractional number or fractional part. Okay, so starting from this one right here, from the decimal or the point right here, so it's being separated by whole number and then the fractional number. So here's the whole number and then here's the fractional number. So as you guys can see, we started with 0 right here and then it's incrementing or increasing by 1. So 0, 1, and then 2. And then for the fractional number, okay, so we started with -1 and then it's now decreasing by 1 or -1. So -1, -2, and then -3. So if you have more right here, then it's now -4. The same with this one right here. If we have more number right here, then it's now 3, 4, 5, and so on and so forth. Okay, so that's basically it, the format on how to convert this any base into a decimal. Okay, and then just add everything and then you will get the result where it's now the converted result from this base to the decimal. Okay, so are we clear so far? All right, so can you guys see my screen? Okay. All right, so let us now continue our discussion. So one thing that I forgot to mention a while ago on why we are talking about number system, what is number system? Okay, that's because that's what or how our computer reads the data. So let me just open another notepad. So as I'm typing right now, let's say I'm clicking A, B, C, D, E, F, G, and so on and so forth. Our computer doesn't read this one as letter A. Let's say I click A, and then it will be read as A, and then it will be displayed as A. No, it doesn't work like that in computer. So this A actually has its own representation wherein if you guys are going to go here at the last slide. Okay, so we are using this ASCII code. Okay, so for example, a small letter A, okay, this one is represented by 97, 61, 141, or even hashtag 97. So it has a lot of different representations. So it could be decimal, it could be hexadecimal, or it could be octal or HTML. So if it's in decimal, then the one that it's being read is 97. If it's hexadecimal, then the one that's being read is 61. If it's octal, then the one that's being read is 141. Okay, so it doesn't can be read as a letter A right away. Okay, so they have their own ASCII representation. Okay, so for capital letters, for small letters, for special characters, the one that we can type in our keyboard. Okay, and then for let's say call this one unprintable. Okay, these things are cannot be printed, or like the shortcuts that we can have on our keyboard also. Okay, and so on and so forth. Okay, so basically this letter A could be a number. Okay, depending on the representation of that letter A. So we have a lot of variations for that. Okay, so I hope you guys got the idea, okay, on why we're talking about number systems right now. All right, so going back to our discussion. So again, just like what I mentioned a while ago, so if it's a whole number, then it starting from 0 and then it's increasing by 1. So 0, 1, and 2. Then if it's a fraction number, then starting from -1 and then decreasing by -1. So -1, -2, and so on and so forth. So yeah, well, for you to be able to understand this one a bit more, let's have an actual example. So we have this conversion exercises. So we have 6 numbers. So don't you guys worry, all of these items right here has their own solution. Okay, so you can find it right here. So solutions to A and B. So here is the letter A. So starting from binary, so we want to convert this one into a decimal. So having this one, just arrange this one from top to bottom. Okay, that's the first step that you can do when it comes to converting any base decimal. So just arrange that one from top to bottom. So starting from here, it's 1, second is 1, and then 0, and then 1, and then 0, and then 1. Okay, and then after that, starting from the last, okay, number or the lowest bit. So of course, since this one is whole number, this is start with 0 and then increment that one by 1. Okay, and then where this multiplier came from, this 2 right here. So this one came from the base. So that is why if you guys are going to take a look on this one, whatever is the base, okay, our initial base right here, that's our multiplier. Okay, so that is why in here our multiplier is 2 because that's the base of this number system. So everything is times 2, and then starting from 0, then it's incrementing by 1. So 0, 1, 2, 3, 4, 5. You can also start right here. However, you have to count the characters that you have in here. Let's say you have 6 characters, right? So just minus 1, okay, because we're going to start with 0. So starting from here, it's 5, 4, 3, 2, 1, and then 0. Okay, so do not put here 6, okay, because we started with 0. So it's always less 1. Then after that, just do the math, just add everything. Okay, you can use your calculator. Then you'll get 53. Okay, and then of course, once you have already converted this base, this binary, into decimal, and do not forget to put the unit, see in decimal, which is 10. Okay, so this is an indicator that you have already converted this binary into a decimal. So did you guys get that one so far? So are we clear, or any clarification on our letter A? So just give me a thumbs up once you have already got the logic, or once you have already understood the letter A. Okay, good. Seems that most of you already got it. All right. So this is just for the whole number. But what about if we now have a fraction number or a decimal number? So it's basically the same idea. Just arrange everything from top to bottom. However, in letter B, it's not arranged from top to bottom. It's actually a zigzag. So starting from here, it's 1, followed by another 1 is now to right. So it's from left to right, left to right, left to right, and then going down. Okay, you might get confused on the arrangement, but yeah, that's the arrangement on this one. So 1 1 is this 1 1, and then 0 1 is this 0 1 right here, and then 1 1 is this, oops, 1 0 is this 1 0 right here, followed by the 1 right here, and then this one now is our fraction number. So that's the reason why we now have raised to negative 1, raised to negative 2, and then raised to negative 3. Okay, but for this part right here, so they are a whole number or an integer number. Okay, so again, starting from this decimal point right here, so it's incrementing by 1, so 0, 1, 2, 3, 4, 5, and then 6. Okay, and then starting from this point again, and then it's now on the fraction number, then start with negative 1, so just decrement by negative 1, so negative 1, negative 2, negative 3, and so on and so forth if you have more numbers on that fraction number. Okay, and then our multiplier is the base of this one, so our base is 2, so just multiply everything by 2, and then again just do the math using your calculator. So in here you can do it manually, of course, but in here, since we have a raised to negative 1, so this one now is 1 half, 1 fourth, 1 eighth, so it's now quite hard to analyze that one using our brain. Well, unless if you're a math genius, then no problem. Okay, so just add everything and then you will get this one, 109.625. All right, so one thing that you guys need to see also or check also is just add everything, okay, for the whole number first, which is equal to 109, and then just add this one also separately, okay, and then you will get 0.625 or 625. So 1 half plus 1 eighth, okay, is equal to 625. Let me just check if you're going to 1 half plus 1 eighth. Yeah, it's 0.625. Hmm. I think you can, yeah. So you can do it in one shot since they are in, you know, proper uh, value, wherein 1 half is 0.5 and then 1/8 is 0.125. Okay, and then it will give you a result of 0.625. Okay, so are we clear so far for the letter A and B? All right, so 3. Okay, so may I know your uh, comment on this one, guys? Is number system hard, or uh, it's still okay to you guys? So can you guys still follow up to this point, or you guys now are confused a little? Okay, so for Mr. Kiwas, maybe it's fine to him, but what about the others? Okay, yes sir, okay lang. Okay, so good to know that. All right, so that's it for the first two examples. Let's now move on to the letter C and D. So just like what I mentioned a while ago, so you can convert any base to a decimal. So we can also convert this octal into a decimal. Okay, so the same concept, just arrange this one from top to bottom. So 4, 5, 3, 6, and then your multiplier is 8. And then starting from here, of course, start with 0, and then it's incrementing by 1. Then just add everything, and then you will get this one. So just recheck this one later on if we have the correct answer using your calculator. But for now, just see the logic, okay, on how did we get this 2398, okay? So are you guys able to follow on how did we get letter C? Is everything normal so far to you guys? Okay. So if you want, you can verify it now so that just in case that, you know, this answer was actually incorrect, then we can change it right away. Okay. How about letter D? Okay. So the same concept, it's just a different number. Okay. So 1, 2, 7, and then 4. And then starting from 7, it's 0, 1, and then 2. Okay. And then for 4, of course, it's just negative 1, erase the negative 1. And then our multiplier is 8 because that's the base of this number system. And then just add everything, and then you will get 87.5. Okay, so please verify. Is this correct? Okay, so coming from Mary Ein, so she said that it's correct. What about the others? Were you guys able to verify whether the answer is correct or no? Or can you guys follow the process on how did we get those results? Okay, all right, so great. I hope the others who are not responding were also able to get this one. Okay, last one is letter E and F. So a while ago we have binary to decimal, and then we have octal to binary. Now we have a hexadecimal to a decimal. Okay, so in here we have V65F. Okay, but remember that in hexadecimal, there are some that's being represented by letter, certain letter, and then they have their own values in decimal. So B is actually 11, and then F is 15. Okay, so starting from 10, it's already A. So just increment it. Okay, 10, 11 up to 15. And then the same with letters. So it's ascending. So A, B, C, D, E, F. Okay, that's basically the pattern that you can remember or you can memorize when it comes to hexadecimal. So B is 11. 6 is still 6. 5 is still 5. And then F is 15. And then our multiplier is 16 since that's the base of our number system right here. And then starting from F, so it's raised to 0 up to the last character, which is 3. Okay, and then just add everything, and then you will get 46,687 pasted. So please verify, check whether this one is correct or no. So is it correct? Okay, great. So I hope the others are also checking this one or verifying this one. All right, so next one now is NBs. So remember that we have decimal. Actually, we have binary, okay, which is 0 and 1 only. Okay, and then decimal is 0, and then that's the normal way to count numbers in computer. But of course, we're going to start with 0. Hexadecimal has a combination of letters, and then octal doesn't have 8 and 9. Okay, and what if we have a base of 3? Okay, so binary has a base of 2, decimal has a base of 10. Nagulo na naman. Anyway, so let me just remove this one. Binary is 2, base 2. Octal is equal to base 8. Decimal is equal to base 10. And then hexadecimal is equal to base 16. Okay, but what if you have a base 3? So we don't actually have a base 1. Well, you can have a base 1, however, we don't use that one anymore. So that's why the minimum one is a base 2. It's either 0 and 1. Okay. So what if we have, uh, let's say, 3 characters? So in here, we call that one base 3. Okay, or not 3 characters. This one is 0 to 1. Let me just arrange this one properly. But what if you have 0 to 2? Okay, it's the best representation of this base 3 right here. So 0 to 2 characters, okay, is called base 3. And then 0 to 4 is called, let me just remove these characters right here. 0 to 4 is called base 3. Oops, my bad. This one is base 0, 1 to base 3. This one is base 4, 0 to 3. Okay, and then if you have 0 to 4, and this one is base 5. If this one has a 0 to 5, this one is base 6. 0 to 7, I mean 0 to 6 rather, it's not 7. And then 0 to, 0 to 7 is base 8. Huh? Ka lang. I'm not confused. 0 to 2 is 3, 4, 5, 6. Base 7. 0 to 7. Ah, yeah. That's correct. So 0 to 7 is now called the octal or a base 8. If you have 0 to 9, I mean 0 to 8, sorry for that. Okay, this one now is called the base 9. And then for the decimal, of course, this one is 0 to 9. Okay, and then for the hexadecimal, this one is of course 0 to 15. Okay, and then 11 is 0 to 10. Base 10, base 11. And then 0 to 11 is base 12. And so on and so forth. Okay, so let me just finish this one. 12, 13, 14, 15. 12, 13, 14, 15. And this one now is 12, 13, 14. So there you go. So we only have 4 proper namings. We have the base 16, base 10, base 8, and then base 2. But the rest, we call them n base already. Okay, so those are 0 to 2, 0 to 3, and so on and so forth. Okay, so I hope you guys were able to get this one. So is it okay so far? Were you guys able to get the logic on, how to separate n base versus the one that has a proper namings, which is, those 4? So how many percent so far that you guys were able to understand this called n base number system? So just let me know if you're confused. Okay, so aside from binary, hexadecimal, octal, and decimal, those are already called n base. So in here we have a base 3. Okay, so we call that one n base. So 12.2 3. So even though it's n base, so still have the same process. Okay, there's no major changes. So in fact, there is no changes aside from the multiplier. So just arrange this one from top to bottom. So 1, 2, 2, and then our multiplier is 3. So times 3 times 3 times 3. And then this one is starting from the decimal. So we have -1, and then this one is 0, and then followed by 1. And then just do the math using your calculator. You will get 5.6666 base 10. Okay, so the same with letter B. So arrange this one from top to bottom, and then our multiplier is 5. And then starting from here, we have -1, and then 0, and then 1 and 2. And then just add everything. You will get 38.2 base 10. So, are we clear so far regarding with this one? Okay. So in here, you don't actually need to remember, what base will it be coming from when it comes to converting it to decimal. Okay. So this one is just a multiplier when it comes to converting this one into a decimal. So you don't need this one is binary. So this is the process that I should follow. This is octal. So this is the process that I should follow. So you don't need to do that one because all in all, they are just the same. Okay, they just differs with how many characters they have, what are the characters that they have, and then what is the multiplier that they have, okay, and so on and so forth. Okay, so everything is pretty much the same. Okay, so more examples when it comes to NB. So we have base 9. Okay, so just arrange this one from top to bottom, 8, 7, 5, 4, 3. Starting from here is 0, incrementing, and then starting from here is -1, and then it's decrementing. Just add everything, you will get this one. So the same with this one, arrange this one from top to bottom. So remember our letters. So you still need to convert them. So A is 10, B is 11. Okay, and then our multiplier is 13. So -1, 0, 1, and then 2. Then just add everything, and then you will get this result right here. Okay, so are we good so far up to this point? So just verify this one later on, as long as you're getting the idea on or the process on how did we get those results. Then you're already good to go. Just verify this the results later on. Okay. Okay, so clear, or anyone who has a question so far? Hello? You guys still around? Okay, so are we good to this point? Okay, so just let me know if you guys need more examples, okay? But that's pretty much it when it comes to converting NBGs to decimal. So you can do anything, okay, as long as you know the process. Okay, it doesn't matter what base is that. So let's now move on to the very default numbers to decimals. All right, so supposedly this will be your city break, but since we are in ODL, so I will not give this one as your city break. So just do this one as your self-study exercise. Okay, so answer this one on a clean band paper if you want. So no need to pass this one anyway, but if you wanted to, let's say, practice and then let me verify whether your answers is correct or no. So just message me. So just take a screenshot of your solution, course of this one, and then you can ask me if you did correct regarding with this exercise right here. Okay. Anyway, so a while ago you can convert binary, octal, hexadecimal, or any base decimal. Well, of course, you can also do the reverse, okay, wherein you can convert decimal into any base. Okay, so to do that one, we have this process right here. So decimal to integer, another base. So number one, repeatedly divide the given decimal number by the base where you want the decimal to be converted to until the quotient is 0. So for each division operation, tally the remainder, and then if the quotient is already 0, write all the tallied remainders by reading them in upward direction. Okay, so for you, again, for you to be able to appreciate this one a little bit more, let's have an actual example. Okay, so before we just keep on multiplying things, but in here, we now need to divide and divide and divide and divide until you will get an integer quotient of 0. Okay, so let's start with this one. So letter A, convert 13 base 10 to binary. So in here, our divisor is where you wanted to convert this decimal. So this decimal is being asked to convert to binary. Then binary now is our divisor. So binary is 2. Okay, so it has a base of 2. So just divide this 13 right here into 2. And then separate the results into two parts. So the first one is integer quotient. And then the second one is the remainder. Okay, so 13 divided by 2 is 6, remainder 1. Okay, and then after that, just get this 1, 6, then put it right here and then divide it by 2 again. So 6 divided by 2 is 3, remainder 0. Okay, and then just get this 1 again, this integer quotient right here. And then 3 divided by 2 is 1, remainder 1. Okay, so take note that you cannot put here, let's say 3 divided by 2. Well, the exact answer of this one is 1.5, right? But since we are talking about integer quotient, so it's integer, so whole number only, then you have to get the whole number result only, which is 1, and then put the remainder on this side right here. Okay, and then the last one, 1 divided by 2 is actually cannot be. Okay, or we could say that yeah, it's possible, but the result is 0.5. So that's the reason why integer quotient is already 0, and then the remainder is 1. Okay, or whatever is that last number right here. Okay, so as a result, the one that you're going to get as your final answer would be the remainder. So 1101. So starting from the bottom, it's 1101. So 1101 base 2. So from 13 base 10, it is now converted into a binary base 2. Okay, so I'll give you guys 30 seconds to 1 minute to analyze this one. So let me know once you have already got the idea or already understand this one. So just give me a thumbs up just to let me know that you're good. Okay, so good so far. There's 6, 7, 8. All right. So another one. So again, you will only stop once you've reached a value of 0 in integer quotient. Okay, and then after that, whatever you have here in the remainder, then that is now your final answer. Okay, so yeah, that's pretty much it for this letter A. So let's have more example, letter B. So 37 base 10 to binary, so still a binary. So our divisor is still 2. So 37 divided by 2 is 18. Okay, remainder 1. 18 divided by 2 is 9, remainder 0. 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. 1 divided by 2 is cannot be. So just put here 0 now, and then whatever is your final number, just put it right here as your final remainder. And after that, you can now read this one from bottom to top. So 100101 base 2. Okay. So in your quiz, of course, we're going to have a quiz on module 4. in your quiz, you don't need to put the base anymore. Okay, so all you need to put is the answer that you were able to solve. So in here, just the put 100101. No need to include the unit anymore. Okay, or the base. Okay, so again, just give me a thumbs up once you're done in analyzing and you were already able to understand this second example. Okay, good. Okay, great. Most of you were able to get it. Okay, next example. So we now have 2010 as a decimal, but in here it is now asking us to convert this one into a octal. So our divisor before is binary, I mean 2, but in here our divisor now is 8 since that's the number that we wanted this decimal to be converted to. So 2010 divided by 8, you'll get 251 point something. So since this is already a large number, so you have to use now your calculator. Okay. So 2010 divided by 8. So in my case, I will get 251.25. So just put here the 251, okay, on the integer quotient. And then the 0.25, just get that one. 0.25, multiply that one to our divisor. Okay, 0.25 times 8, then it will give us a remainder of 2. Okay, so that's how we've got the value of remainder. So 0.25 times 8. Okay, so were you guys able to get that one? The 251 and then the 2 on the remainder. Okay, well, if you want, you can do this one using the old way, like elementary days. It doesn't want to be deleted. Ah, sleeping tool pala. Okay, like, what is that again? 251, 2010 divided by 8. 2010 divided by 8. So in here we have a 16. So 2 minus 16. So it's 4. Bring down 1. 8, 16, 80, 42, 40. It's 5. Ano ba? Mamaya mali pala ginagawa ko. So it's 40. So 5 times 8 is 40. So minus 41 minus 40 is 1. So bring down 0. So 8 is 1. Minus 8, so 2. So whatever is the last one right here, that's now your remainder. Okay, so this is your integer quotient, and then this is your remainder part. All right, so you can do this one if you want. Okay, well, if you don't want to write, then you can use your calculator instead. All right, so that's how we've got this 251 and then 2 right here. And then again, just get this 251 divided by 8. Okay, so in my case, I'll use my calculator since this one is a lot easier. 251 divided by 8. We've got here a result of 31.375. So 31 for the integer quotient. And then 0.375 times 8 will give us a result of 3. Okay, and so on and so forth. So 31 divided by 8 is 3, remainder 7. 3 divided by 8 is cannot be. So just put here 0, and then whatever is our last integer quotient, just put it here as your final remainder. Okay, then you can now get the final result on the remainder. So 3732 base 8. Okay, so I hope you guys were able to get this one. So if you have questions or clarification, so feel free to ask that one on the part 3. So goodbye for now since you don't have enough time anymore. So let's just meet again on the part 3. Okay, so hello again for 8, 12, 16. Okay, so that's 4. So before we were 20, I guess, or 18. Anyway, so hello. So let me just check if you guys are already in front of your monitor or smartphone. So just give me thumbs up. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so almost half, 60% or 70%. Okay, so do you guys have a question so far regarding with this one? So are we clear on how did we get the result of 3732 base 8? Okay, so 3 out of 17, 4 out of 17, 5, 6, 7. Okay, good. So again, don't be shy to ask if ever that you're confused into into this part or that part. Okay, so I'm willing to help. Okay, I won't get angry. Okay, that's okay if you didn't understand it. It's part of learning. So the next one right here is still 2010, but it's now asking us to convert this one to hexadecimal. So before we have a divisor of 8, but of course since we now have hexadecimal, so we now have a divisor of 16. So again, just use your calculator. 2010 divided by 16 will give us a result of 125.625. So 125 for the whole number, and then 0.625 times 16 is for the remainder brain. It's 10, so you can actually convert this one already. So 10 is equal to A in hexadecimal. So moving on, since this one is still not yet 0, so 125 divided by 16 will give us a result of 7.8125. So 7 for the integer quotient, and then 0.8125 times 16, which is equal to 13 for our remainder. Okay, wherein 13 is letter D in hexadecimal, and then 7 divided by 16 is cannot be. So again, just put here 0, and then whatever is the final number in the integer quotient, just put it as our remainder. Okay. So yeah, once this one's twice 0, then you can read the remainder part from bottom to top. So this one is 7b8 base 16. So let me know if you already understand this one. Okay, great. All right, so see, everything in midterm is super easy. Okay, so I would say that this is already the hardest part, you know, especially if you didn't really try to understand what's happening on the module 4. Well, for the rest, let's say module 1, 2, 3, 5, and then 6. So you can, number 6 is also need time to be study. Okay, but for module 1, 2, and 3, and then 5, so they just need common sense, especially if you're a computer literate. Okay, well, I'm pretty sure that most of you, loves playing. So most of them, you already know them. Okay, but before, like at the year 2010, 1990s, so most of the people needs to learn the basics. But right now, just by exploring the things in front of your computer, you are already learning the basics. Okay. All right, so that's it for the letter D. Let's now move on to the letter E. So convert 2010 base 10 to base 12. So again, the only one that differs is the divisor. So the same process, 2010 divided by 12 will give you 167, and then the remainder or the fraction part, you have to multiply that one to our divisor. You will get 6. 167 divided by 12 is 13, and then whatever is the fraction part or the decimal part, just multiply that one to 12, and then you will get 11, and then convert this one already into letter B. Okay, and then 13 divided by 12 is 1, remainder 1, and 1 divided by 12 is cannot be, so just put here 0, and then since this one is already 0, then you can read this one from bottom to top. Okay, and then whatever is the final number on the integer quotient, just put it right here on the remainder. Okay, so our answer right here is 11b6 base 12. So please verify, and then let me know if the answer right here is correct or no. Okay, okay, very good. Miss Jaline Damaslab. Correct, sir. Okay, great. So, and here, as long as you know the process, okay, you can verify this one later on. Okay, just in case that you wasn't able to understand this certain item, then as long as you know the fundamentals, then you can always go back to that specific number and then verify that one again if it's correct or no. Okay, and then here is another, self-study exercises. So again, supposedly if we are in a face-to-face method, we're going to do this one in a 1/2 sheet of paper. But since we are in ODL and then there's too much to do, okay, so I'll only give you guys one quiz, okay, one quiz per module, and then the rest is now your free time to finish your laboratories. Okay, so again, just do this one on a clean sheet of paper, and then if you want me to check your work, if you're not sure if it's correct or no, then just send me a message. Okay, just take a picture and then send it to me, then I'll verify it for you. Okay, so the next topic right here is conversion of decimal fractions to another basis. So before we have a decimal only, wherein it's a whole number decimal, but in here we now have a decimal fraction, or it's literally has a fraction part. Okay, so here are the steps. So repeatedly multiply the given decimal fraction by the base. Like for example, you want to convert it to decimal, or I mean binary. So just multiply that one by 2. If you want to convert this 1 to octal, then just multiply that 1 to 8. You want to convert that 1 to hexadecimal, then just multiply that 1 to 16. Okay? Depending on the you want that to convert it into. Okay? So that will be your multiplier. And then separate the product's integer from its fractional part, and then record the product's integer. And then if the product's fractional part is already 0, write all the tallied product integers by reading them in downward direction. Okay, so again, we cannot dissect this one by one. So the best way for you to understand this one real quick is by having an actual example. So let's have this example number 1 when it comes to decimal fractions to binary. So convert 0.625 base 10 to binary. So it wanted us to convert this one to a binary. So our multiplier now is 2. Okay, so just get this one, 0.625 times 2, okay, and then separate the results into 2. So the first one is integer, and then the other one is fraction. So 0.625 is 1.25, so just separate them literally. So 1 right here, and then 0.25 right here. And then the one that you need to get is the fraction part, okay, not the integer one, okay, it's the fraction part. So 0.25 times 2 will give us 0.5. So 0 for the integer, and then 0.5 for the fraction. And then 0.5 times 2 is 1. And then 0 now for the fraction. So the only time that you will stop multiplying is once you've got a value of 0 on the fraction part. So in here, it's already 0, so you can stop multiplying. And then you can read the result from top to bottom on the integer part. So it's 1, 0, 1. But since we're talking about decimal fraction, so you have to make this one as a decimal. So the final answer is 0.101. Okay? Okay, so just wait a second, guys. Okay, so sorry for that. So are we clear so far regarding with this example, decimal fraction to a binary? Okay, so again, if ever that you have a question, so feel free to ask me right away, okay? Okay, so that's it for this decimal fraction. So let's now have the second example. So again, it is still a fraction, so 0.6875, and then it is still asking us to convert this one to binary. So our multiplier is still 2. So 0.6875 times 2 will give us 1.3750. So with this one, you can just simply use your calculator, okay, to avoid incorrect answer. So 1 for the integer and then 0.375 for the fraction, okay? And then just get this one, 0.375 times 2, you'll get 0.75. So 0 for the integer and then 75 or 0.75 for the fraction. So just get this one again, 0.75 times 2 will give you 1.5, so 1 for the integer and then 0.5 for the fraction. So 0.5 times 2 is 1, okay? And then 0 now for the fraction. So actually there's already a, you already know that this is already the last one that you have to multiply because 0.5 times 2 is already equal to 1 and then the fraction part is already 0. So it's like, an indicator that this is already the final multiplication part that you need to do. So once this one is already 0, then you can read the integer part from top to bottom. So 1011 base 2. Okay, so correction with this one should not exist. So it's 0.6875. So are we clear so far? Did you guys get the idea or the logic? Okay, great. So 5 out of 18. 6, 7. Okay, great. So another example is, of course, another decimal fraction, but of course, it's now asking us to an octal. So before it's just a binary, but our multiplier now is 8. Okay, so 0.359375 times 8 will give us 2.875. So 2 for the integer product and then 0.875 for the fraction. Okay, so just get this one again. 0.875 times 8 will give us exactly 7. So once this one is already 0, then you can now stop multiplying. So the final answer for this one is 27 base 8 or 0.27 base 8. So please check using your calculator whether this one is correct or no. Okay, very good, Mr. Kiwas. Very good, Mr. Christopher, and then Mr. Kiano. Mr. Kiano, how are you related to Sir Austria, the Dean of, CTE ba yun? Teacher Education? Kaapelido lang. I thought he was your maybe uncle or maybe even father. Who knows, right? Okay, so if everything is very good with example number 3, then let's now move on to the next one wherein it is now the complete version of a whole number and a decimal fraction. So this is a decimal whole number and then a decimal fraction. Okay, so it wants us to convert this one into hexadecimal. So that's pretty easy. Okay, so you can actually do this one in two parts. So the first one is for the whole number only, and then the second one is for the fraction part only. So we cannot combine them as one since those two have different process. Okay, so in here we're getting the remainder, but in here we're getting the integer part. So that's why we have to separate those two. So 3023 for the whole number, and then 0.3203125 for the fraction part. Okay, so as long as you know the process for the whole number, then you're good to go. So in here, for the whole number, so it will be a divisor. Okay, so divisor, which is hexadecimal, so 16. But for the decimal fraction, it would be a multiplier, okay, which is times 16. So it's one major difference when it comes to solving a whole number versus a decimal fraction. Okay, so in here, 3023 divided by 16 will give us 188 point something. So that point something must be multiplied with 16, and then you will get 15. Okay, and then just convert it 1 to f right away. And then 188 divided by 16 will give you 11 point something. So that something must be multiplied to the 16, and then you will get 12. And then you can convert this one already right away into C. Okay, and then 11 divided by 16 is cannot be. So you have to put this one here now is 0, and then whatever is the final number right here will be now your final remainder. Then you can now convert this 11 into B, and then you can now read this one from bottom to top. So the final answer for the whole number is BCF. So just keep it for now, and then you can now move on and start answering the fraction part. So 0.3203125 times 16. Okay, so again, it's now a multiplier since that's the process that we need to do when it comes to decimal fraction. So you will get here 5.125. So just separate those two results. So 5 for the integer part, and then 0.125 for the fraction part. So just to get this one again, 0.125 times 16, you'll get exactly 2. Okay, remainder 0, or fraction part 0 rather, not remainder. So once this one is already 0, then you can now start reading the integer part from top to bottom. So it's 0.52. Then you can now combine them as 1. BCF that 52. So I'll give you guys 30 seconds to 1 minute to analyze this one, and then just let me know once you already got this one. All right, very good. Okay, so 5, 6, I think 6 out of 18. We're already able to get this one. Okay, that's actually it for the decimal. So more exercises that you might want to do to practice on how to convert the integer and then decimal fraction into a binary, base 4 or base 12. So the same with this one, to base 5 to base 15, and so on and so forth. Okay, and then again, just send me a message. Okay, there is a question. So paano ulit nakuha yung 15, sir? Where is the 15? This one right here? This is the one that you're talking about, 15? Okay, so 3023 divided by 16. Just put this one on your calculator. Okay, and then you will get 188 point something, right? And then just multiply that something, okay, to 16, and then you will get 15. So 3023 divided by 16. In my calculator, I've got a result of 188.9375. Okay, so 0.9375 times 16 will give us a result of 15. Yeah, that's it. So thank you, Mr. Kiwas. Okay, so the same with the other remainder right here. And then, for your question, Mr. Kiano, sir, sa kanwas po ba magsasend ng message if magpapacheck ng solution? Yes. So you can message me either to my Canvas or to my Facebook account. Okay, so either of those two. Okay, just attach the image. Okay. Any other question? All right. So was I able to answer your question, Mr. Kiano? Okay. All right, so let's now move on to the summary on what are things that you can do to this bases. So decimal can be converted to n base can be converted to decimal can be converted to binary can be converted to decimal, and so on and so forth. Okay. So in here, let's now talk about hexadecimal to binary conversion. So, this one is actually the first topic that we had. So going back right here, it's just the opposite of that one. Okay, binary and then decimal. But we can also do the binary to decimal. Okay, as long as you know the logic on how to, evaluate this decimal into a binary, then you're good to go with this next topic. Okay, so 000 is equal to 0, of course, and then 0001 is equal to 1. Okay, and then 11111 is equal to f or equal to 15. Okay, but take note, when it comes to converting a hexadecimal to binary, you have to represent each hex digit to 4 binary bits, meaning you have to separate them by 4-bit. Okay, one character is 4-bit, another character is 4-bit, another character is 4-bit. Now, for you to be able to understand this one, let's have an actual example. So this character is 4-bit, another character which is f is 4-bit, another character is 4-bit, another character is 4-bit. So if we have 4 characters, then just multiply that one by 4, and then that's the total bit number that you will have as your final answer. So 4 times 4 is 16. So if you're going to count this one, we have 16 characters. Okay. So to start with, you can start either on the left side or on the right side. Okay, so you can start here if you want. Okay, or you can start here if you want. So either of those two. So the representation of 5 is 0, 1, 0, 1. So you need the 4 and 1 for that one. And then F is 1, 1, 1, 1. And then A is 10. So you need 8 and then the 2. And then for the 1, so it's 0, 0, 0, 1. So you can already answer, you can already have this one as your final answer. But you can reduce this one by removing the other 3 zeros right here, because since we're talking about binary, it will not affect the result of your answer. Okay, since we are reading this one from the lowest bit to the highest bit. Okay, so this one is the first character, if it's on the right, second, third, and then fourth. Okay, and then don't forget to put the base. So are we clear so far? Did you guys able to get this one? The number 1? Okay. Alright, so great. So the same thing if we have a decimal, okay, decimal or fraction part. So just separate them still, every 4-bit or every character. So 4-bit, 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 4-bit. All in all, you have a total of 16 bits right here. So D is 1101. So A, B, C, D. So it's 9 plus 4, so it's 13. So you need 13 right here. So 8 plus 4 plus 1. So 1101 is 13 or equal to letter D. So 6 is 4 plus 2. So 0110. And then 0 is, of course, just 0. And then 3 is 0011. Then again, you can remove this other 20 for you to have this shorter answer. Then wherever is that decimal, just put it right here to represent that this is the whole number and then this is the fraction number. So clear on example number 2? Okay. All right, so great. More and more is now able to understand this topic. Okay, but what about binary to hexadecimal? So if you can do hexadecimal to binary, of course you can do the other way around. So binary to hexadecimal. So still, you have to group this binary to 4-bit to avoid confusion. So this is the original given number. So just separate them every 4-bit. So starting from the lowest bit going to the highest bit. So starting from here, so 4 characters, which is already this one, and then the dot or the decimal point, and then another 4 characters, which is this one, another 4 characters, which is this one, and then another 4 characters, which is this one, and then 1 1, and then 1 1. So for formality's sake, just add 2 zeros again. Okay, so those two are just the same. So 0, 0, 1, 1. Just to represent that this one is in a 4-bit group. Then after that, you can now, get the individual results of those binary combinations. So 2 plus 1 is 3, 8 plus 1 is 9, 4 plus 1 is 5, 4 plus 1 is 5, and then 8 plus 4 plus 1 is 13, which is equal to letter D. So as a result, this is now the hexadecimal number or output. So 3955.D base 16. So again, just give me a thumbs up if everything is clear, and then just ask a question right away if you're quite confused. Okay, great. So dumadami na ang nakakakuha. So very good. Next one, we also have octal to binary. Okay, however, the difference of hexadecimal versus octal. Hexadecimal must be grouped by 4. Okay, while in octal, okay, you must group them by 3-bit. Okay, why? That's because, in hexadecimal, you need 4 bits for you to be able to form the whole set of 1 to 15. Okay, so starting from, let's say, 0, okay, going to 15. So this 0 right here is represented by 0, 0, 0. And then going to 15, you need 1, 1, 1, 1. So as you guys can see, you need 4 bit for that. But for the octal, okay, so it's being represented by 0 to 7. And 0 is 0, 0, 0, so you need 3-bit only. And then 1, 1, 1 for 7. So as you can see, you don't need 4-bit on this one. Okay, you don't need to say 0, 0, 0 or 0, 1, 1, 1, 1. Okay, you can have only up to 3-bit. So what happen if you're going to exceed to 1? Let's say you have the other one here as 0 to 0 to, let's say, 10. Okay, and that one is now 0. Bakit 0? Yeah, n base kasi ito eh. So wala tayong pangalan. Call this one n base. N base of 10 na lang. Okay, to make it more easier to understand. And then n base 10, okay, is 0 to 9. Okay, so in here you need 4 characters. That's because we need to represent this 9 right here. Okay, this 9 right here using a 4 characters. So 8 and then 1. Okay, so it's 1, 0, 0, 1. Okay, unlike in octal, you only need up to 3-bit. Okay, so 1, 1, 1 is already equal to 7. So 4 plus 3 plus 1. 4 plus 2 plus 1 rather. Okay, so are we clear so far on why do we have 4 bits in hexadecimal, and then why we only need 3 bits for the octal, and then why we need, let's say, 4 bit if it's already exceeding octal, let's say base 9, base 10, base 11, base 12, and so on and so forth. Okay. Okay, so again, that's the reason why we have to group this one every 3-bit only. So 3-bit, 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 and then 3-bit. So 5 is 101, 7 is 111, and then 1 is 001. Then again, you can remove this 20 to have a shorter answer. And then don't forget the base 2. So it's an indicator that I have already converted this octal into a binary. Okay, so did you guys get this one so far? Octal to binary? Okay, great. All right, so let's now move on to the next one. So if we can do octal to binary, of course, we can do the other way around. Binary to octal conversion. So of course, we'll be given this as original combination of binary. But since we're asking to convert this one to octal, so again, you have to group this 1 by 3. Okay, so if you're going to group this 1 by 4, then you are already getting the incorrect answer. Okay, so don't forget that in octal, it should be grouped by 3-bit only, or every 3-bit. So 101, 101, 011, 011, 101, 101, 010, 010, 001, 001, and then 11 or 011. Okay, then after that, you can now get the specific result of those each 3-bit. So starting from here, we have 4 plus 1 is 5, 2 plus 1 is 3, 4 plus 1 is 5, and then 2, and then 1, and then 3. So 2 plus 1 is 3. Then wherever is the decimal point, then just place it in there. So you'll get a result of 3125.35 base 8. So clear? Okay, very good. All right, so here's the summary wherein you can convert decimal to NBs, etc., etc. So yeah, just read this one. So there are things that you cannot convert right away. Like for example, where is that one? Here. So you cannot convert octal to n base right away. Okay. So for you to be able to get the n base, so you have to do double conversion. Like for example, octal going to decimal, and then decimal going to n base. So you can also do the other thing. Let's say octal to binary, then binary to decimal going to n base. So you can have triple conversion, quadruple conversion if you wanted to. Okay, for double conversion. Okay, but there are things that you can convert right away, like decimal to octal, octal to binary, hexadecimal to binary, and so on and so forth. But there are things, again, that you need to have a double conversion or triple conversion. Okay, so again, just and more activities. Okay, supposedly this will be your assignment, but since we are an ODL, so you don't need to do this one anymore. Well, if you want to, have some practice exercises, you can include this one. Again, you can send your solution on the my canvas for me to check whether your answers are correct right now. Okay, so the next one right here is operations on numbers. But since we don't have enough time anymore, so we'll just continue this one tomorrow. Okay, we'll finish the remaining slides, so 41 to 63 tomorrow. Okay, so the same time, 8 a.m. up to maybe 2 meetings only, so part 1 and part 2. So depending on how fast we can finish the remaining topics. So for now, that's it. And if ever that you have a question, so feel free to message me anytime. Okay, well, if you have a question now, please ask that question of yours now, since we still have 2 minutes left. Maybe we can uh, find a remedy on that question of yours right now. So no question. Okay, so just give me a thumbs up if everything is already good. You were able to understand everything. Okay, great. Okay, so I need your feedback, guys. So, uh, in, is my pace just fine, or am I too fast? Is it the right pace, or you guys need to, or you wanted to have a slower pace of discussion? Okay, so coming from Mr. Giano, sakto lang daw. Okay, so if you guys would like to have a slower pace, so let me know. Okay, since I think, yeah, in my case, that's how I explain things basically. So it's quite fast, but as long as you guys were able to understand how I explain things, then I guess no problem with that. Okay, so if you guys don't have a question anymore, then you may now go. Let's just meet again tomorrow. Okay, so don't forget to answer now the quizzes, the module 1, module 2, and then module 3. Okay, so goodbye and thank you guys for coming.
Goodbye and thank you, sir.
Goodbye and thank you too. Thank you too. Thank you too. Okay, thank you. Okay, so sir, kailan po due date ng lab 4? Ko ba nalagay doon? Lab number 4. 5. Ah, I forgot. So this is also July 2. Okay, so the same due date with the module 3 quiz, and then the case study number 3. Okay, so thank you for that one. So I forgot to put the due date of this one. So this is also July 2. Okay, so thank you for that one, Miss Feby. Okay, so any other concerns so far? Okay, and then for lab number 5, 6, and then module 4 quiz, and then case study number 4, the due dates will be July 10. Baba ka muna. Yeah. Okay, so sorry for that. My cat is, keep on climbing up on my desktop. So, napunta siya sa harapan ng camera. So, kailangan kong tanggalin. Okay. So, any other concerns? Okay, so I think wala na. Okay then, so let us now proceed with the operations and numbers. So we're going to talk about binary, octal, and then hexadecimal. Okay, so first is the binary addition. So this is just super simple. So binary addition is very simple, same rule as decimal. So in here, 1 plus 1 is 10, 1 plus 1 plus 1 is 11, 1 plus 1 plus 1 plus 1 is 100, and so on and so forth. Okay, so anybody who has an idea why 1 plus 1 is 10, not 1 plus 1 is 2? Anyone? On why 1 plus 1 plus 1 is 11, not 3? Okay, let me ask someone randomly. Mr. Kiwas. Mr. Kiwas? So
Sir, ano ulit yung tanong?
do you have an idea why 1 plus 1 is 10 in binary?
Sure, no.
Okay, what about the others? Anyone? Okay, Mr. Urven, Kent Max. Hello, Mr. Urven or Urven? Okay, so maybe he's not around. Okay, what about you, Miss Jeline Damaslog?
Sir, no idea.
Okay. Alright, so it seems that most of you, this is your first time encountering this kind of addition. So it is still the same, with our normal math. So 1 plus 1 is 2, right? But since we're talking about binary, so remember that in binary, we only have 0 and 1. Pangit naman nun. 0 and 1. Okay? So, we cannot write 2 as a result. So, how do we represent 2 in binary? So, in binary, it's a 0, 0, 1, 0. Okay? And as you guys can see right here, you can remove the 2, 0. Okay, this one right here, we can remove that one. And then the remaining answer will be 10. So that's why 1 plus 1 in binary is 10, or 1, 0. Okay, because you have to activate the 2 in here. Okay, so the same uh, concept with the 1 plus 1 plus 1 plus 1. Okay, the 3 ones. So in here, this one should be 3, right? But in binary, it's 0, 0, 1, 1. So you can remove this one again. So the final answer would be 11 or 1, 1. Okay. So are you getting now the idea, guys? Okay. So the same concept if we have 4 ones. Okay. 1, 1, 1, 1. So this one is equal to 4, but in binary, it's 1, 0, 0, or 0, 1, 0, 0. So you can remove this one. So the result for this one is 100. Okay? So that's basically it. So if you want to add binary, so it's still the same. Just get the total sum, but after that, you have to convert that decimal number into a equivalent binary result. Okay? So you can also base it on this table. So 1 plus 1 is 10. 0 plus 0 is 0. 0 plus 1 plus 0 is 1. What else? Uh, 0 plus 1 is 1. And yeah, those only. Yeah, so that's it for the binary addition. So let's have a simple example. So getting this one, so 1 plus 1 is 10. Okay, so carry 1, bring down 0. 1 plus 1 is 10 again. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. Carry 1, bring down 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. Carry 1, bring down 1. 1 plus 1 is 10. Carry 1, bring down 0. And then bring down the carry. Okay, so this is not the result for the example number 1. Okay, so yeah, were you guys able to get this one?
Yes, sir.
Okay, great. So easy, right? Super simple. Okay, so I will not answer number 1 and number 2 anymore since those examples are similar with this example. So let's just answer one number with 3 and 4. So which one would you guys like? Is it 3 or 4? What number? So if you want 3, just give me thumbs up and then I'll count it. How about 4? Okay, so let's go for number 4. Nangyari. Copying to clipboard. Okay, just wait a second. May napindot akong iba. Okay, so let us answer this one. So 0 plus 1 plus 0 is 1. 1 plus 1 is 10. So carry 1, bring down 0. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 3 zeros is 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 3 zeros is 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 plus 1 is 4, so it's 100. So in here, you need to put the carry on this one first for the 1, and then followed by the 0 on the second one. Okay, so you cannot put the 10 on one column only. So you should separate them. So 1 for this column, and then another number for this column, and then bring down the 0 right here. Okay, so 0 plus 1 is 1, and then 1 plus 1 is 10. Carry 1, bring down 0, and then bring down that carry. And then for the decimal, so it's still right here. Okay, then after this, you're gonna group this 1 by 4 for uh, you know, a better representation of your answer. So were you guys able to follow so far? Okay, so again, just remember, if it's 100, if it's carried to 100, so let me just give you another real quick example. Okay, let's have this example. So if it's 4 1, so this one is 100, right? So we have to put the first carry in here, and then the second carry, and then bring down 0. So that's how you put carries if you have 2 or more. Okay, so 0 plus 1 is 1, and then 1 plus 1 plus 1 is 11. All right, so I hope this one is clear to you guys. So any questions so far regarding with the binary addition?
Answer.
Okay, so if you guys don't have a question anymore, then let's now proceed to binary subtraction. Okay, so this one is also super simple. Okay, same rule, still as a decimal. So there's a correction with this one. So this one is binary subtraction. Okay, not binary addition. So in here, of course, 1 minus 1 is 0, but 0 minus 1 is cannot be. Okay, so that is why you have to borrow on this neighbor of yours. So this one now, of course, will become 0, and then this 0 will become 10. Okay, so that's how things go in here. So to make this one simple, okay, so in binary subtraction, so if you're going to borrow, let's say this 0 right here will borrow to this neighbor of him. So of course this 1 will become 0, but this 0 will become 2. Okay, so 2, but in binary this one is 10, right? So you're going to put here 10. Okay, that's how things go in uh, binary subtraction. So this one is super similar also with how we subtract things, and then if we borrow things, let's say from 0 it will become 10, from 15 it will become, I mean from 5 it will become 15, and so on and so forth. So you're borrowing 10 from this neighbor of yours. Okay, but in here actually you're making that one into 2, not 10. Okay, it's just that this 10 in here has an equivalent value of 2 in decimal. Okay, so yeah, so that is why if you're going to deduct 1 in here, let's say minus 1, this one is not equal to 9. This one is equal to, so 2 minus 1 is 1. Okay, since this one has a value of 1 in decimal, this one has a value of 2 in decimal. So 2 minus 1 is 1. Okay, so I hope we are clear with this one upon how we borrow things when it comes to subtraction. Are we somehow clear? Were you guys able to get the logic?
Yes, sir.
Okay, so just let me know if you're quite confused. So let's answer this one now. So 1 minus 1 is of course 0. 0 minus 1 is cannot be, so we have to borrow. So this 1 will become 0, and this 0 will become 10. And then 10 minus 1 is 1. Okay, 0 minus 1 is again cannot be, so we have to borrow to this neighbor of yours. So 1 will become 0, 0 will become 10. Okay, 10 minus 1 will become 1. 0 minus 0 is still 0, 1 minus 1 is 0, 1 minus 0 is 1. Okay, so let's compare our answer. We have the same, so 1, 0, 0, 1, 1, 0. All right, so are we clear so far regarding with this example? Okay, great. So if ever that you have a question, so don't be shy to ask, okay? Okay, so again, we will not answer number 1 and 2 since this one is super similar with this one. So the one that we're going to answer is the one that is a little bit more difficult. So in this case, I'll choose number 3. Okay? Oops. Naglalag na yung aking laptop. It's happening. Guess I need to buy a new one. But I don't have the money. So sad. Anyway, so let's now answer this one. So let's start from above, of course. So 0 minus 1, this cannot be. So we have to borrow to this neighbor of yours. So 1, 1 will become 0. Okay, 0, yeah, 0 will become 10. Okay, and then 10 minus 1 is 1. Okay, and then 1 minus 0 is still 1. So did you guys get that one so far? Are you guys able to follow on this column? Okay, great. So let's now move on to the next one. So 0 minus 1 is again cannot be. Okay, so we have to borrow to this neighbor of yours. But there is a problem. So this neighbor of yours doesn't have anything, so he cannot let you borrow. Or even though he wants to, okay, he won't be able to give you something. Okay, so sorry for that, Mr. Palagi or Miss Palagi. I have to mute you. All right, so let's go back here. So 0 minus 1 is again cannot be, so we have to borrow, but this neighbor of yours doesn't have anything. So this neighbor of yours have to borrow to, okay, have to borrow to his neighbor first. So in here, 1 will become 0, and then 0 will become 10. Okay, so now he now have the money, so we can now borrow something. So 0 will become 10, and then of course this 10 will become 1. Okay, so isa lang mababawas sa kanya. Okay, so he borrowed to his neighbor and then he got 2, and someone borrowed to him. Of course, there's parang ganun, medyo madaya nga eh, to be exact. So you're going to borrow 2, but if someone will borrow to you, uh, you'll be only deducted by 1. Okay. So parang mas maganda pang meram ka na lang and then magpahiram ka na din kasi merong matitirang isa sa'yo. So yeah, that's how things goes when it comes to subtraction in binary. Okay, so now we can now deduct this 10 right here since this is now possible. So 10 minus 1 is 1. Minus 1 is 0. Oops. Okay. So were you guys able to follow on the second column? Okay, so I'll give you guys 10 seconds to, analyze. Okay, great. All right, so let's now move on to the next one. So 1 minus 1 is 0. Okay, let me just cancel this one now. So we now have 0 right here. And 0 minus 1 is cannot be, so we have to borrow to your neighbor. But that neighbor of yours doesn't have anything. So this one have to borrow first to his neighbor. So this 1 will become 0, and then 0 will become 10. Okay, so you can now borrow to this neighbor of yours since he has now a money. So 10 will become 1, okay, and then 0 will become 10. Okay, so now we can deduct this one now. So 10 minus 1 is 1. So did you guys get that one so far? The third column? Okay. All right, so great. So let's now move on to the fourth column. So this one is already canceled. So 1 minus 1 is 0. So let me just cancel this one and this one also. So we now have 0 right here. And 0 minus 1 is cannot be. So we have to borrow again. So same concept. This one has to borrow first to his neighbor since he doesn't have anything. So 1 will become 0. 0 will become 10. 10 will become 0. And then 0 will become 10. Ah, my bad. This is not 0. Okay, 10 will become 1. Okay, so it will be deducted by 1 only, not 2. So now we can deduct this one now since this one now is valid. So 10 minus 1 is 1. Okay, so are we still clear? Do we have the same result as what you are thinking? All right. Okay, very good. So let's now move on to the fifth column. So 1 minus 1 is 0. So cancel, cancel. Okay. So 0 minus 0 is, of course, is still 0. Okay. Moving on to the next one. So 0 minus 0 is 0 minus 0 is still 0. So just put here 0. 1 minus 1. So, of course, it's already 0. So just put here 0. So 0 minus 1 is cannot be. So we have to borrow to this neighbor of yours. So 1 will become 0. 0 will become 10. And then 10 minus 1 is 1. Okay. And then 0 minus 1 is cannot be. So we have to borrow to this neighbor of yours. So same logic. This neighbor of yours have to borrow first to his neighbor because he doesn't have anything. So 1 will become 0. And then 0 will become 10. And then you can now borrow to this neighbor of yours since he has now money. So 10 will become 1, and then 0 will become 10. 10 minus 1 is 1. So are we clear up to this point? Okay, very good. So 1 minus 1 is 0, and then 0 minus 1 is cannot be, so we have to borrow. So same logic, since this one doesn't have anything, so he has to borrow first. So 1 will become 0, 0 will become 10, 10 will become 1, and then 0 will become 10. So 10 minus 1 is 1, minus 1 is 0. And then right here, 1 minus 0 is 1. And then 0 minus 0 is 0. Okay, so this is now our final answer. So, did you guys get this one so far? All right. So, I would say that this is the one of the confusing part when it comes to binary addition or subtraction. So addition is super easy. Subtraction is kinda tricky, or let's just say that it's kinda messy. Okay? So marami lang siyang mga carry, carry, borrow, borrow. But once you've got the logic, it's super easy already. Okay? So yeah, that's it for this example for the binary subtraction. So the next one is octal addition. So we also have octal addition. Okay? So in here, everything seems normal. 2 plus 3 is 5. 5 plus 1 is 6. So I guess you guys don't have a problem with letter A. But on letter B, 7 plus 1 is 10. So carry 1, bring down 0. 1 plus 2 plus 3 is 6. So remember that in octal, we don't have 8 and 9. So what will happen? What will happen if we have a result of 8? So again, it is already 10. So you'll jump next to 10, okay? Since you don't have 8 and 9. So going back with our, I actually saved the notepad. So when going back right here, so we have the decimal. This is the normal way on how to count things in, with us human and then the computers. But in octal, so it has a different method. So 0 to 7 is the same for the octal and decimal. But once you reach 8, it's already 10. So that is why in here, 7 plus 1 is 8, but you have to write here 10. Okay, since we don't have 8 in octal. And then of course 1 plus 2 plus 3 is 6. So that's the reason why we have a result of 60. Okay, not 58. So are we clear so far regarding with this one?
Yes, sir.
Okay, very good. So let's answer letter D. Okay, yeah, letter D. So it's 52.7 base 8 and then 76.4 base 8. So 4 plus 7 is 11, okay? But if we are going to take a look on that one right here, so 11 in decimal, but in octal it's already 13, okay? So just put here 13. So carry 1, bring down 3. 6 plus 2 is 8, plus 1 is 9. So 9 in decimal, but in octal it's 11. Okay, so carry 1, bring down 1. 1 plus 5 plus 7, so it's 13. So 13 in decimal, but in octal it's 15. So carry 1, bring down 5, and then bring down the carry. And then the decimal would be right here. So the result of this octal addition is 151.3 base 8. Okay, so were you guys able to follow so far? Alright. So the best method that you guys can do is you must have a list of this one, a copy of this one. So if you want, you can take a screenshot of this one, okay, so that you can have your own reference. So let's say in addition for let's say in 24, but in hexadecimal you have to write 18, and then in octal you have to write 30. So you guys have to follow this certain sequence. Okay, it's not exactly 24, but it's 18 or 30. So depending on the number system. Okay, so that's it for the octal addition. Let's now move on to the hexadecimal addition. So in here, 4 plus 6 is 10. So again, if you guys can still remember, 4 plus 6, 10 in hexadecimal is letter A. Okay, so that is why we have put here A as a result. And then 7 plus 2 is still 9. Okay, but in here, 7 plus 9 is 10. So again, how did we get 10? Because if you guys are going to take a look on this one, 7 plus 9 is 16. So in hexadecimal, it's 10. So that's the reason why it's carry 1, bring down 0. Okay? But how about this one, sir? So 1 plus f plus e. How did we get this 1e right here? So you can get the value of this one first. Let's say f is 15, right? And then e is 14. Am I correct? 15 and then 14 ef. Let me just check. Okay, yeah. E is 14, f is 15. So 14 plus 15 is 29. 29 plus 1 is 30. Okay? 30 in hexadecimal is 1e. So that's the reason why we have a result here of 1e. Okay? So were you guys able to get that one? Okay, so as long as you have this reference, so you'll never go wrong with your answer. Okay, so as long as you know the logic on how did we come up with this kind of sequence, then you're good to go. Even though you have, let's say, up to 70 of result, 80 of result, so just have a list of that one. Okay, so in here, let's just answer one. Okay, so let's answer letter E. So B A dot B E plus FAFA F A dot F A. So B plus FAFA. Okay, so E again is 14 and then A is 10. So 10 plus 14 is 24. And in hexadecimal, 24 is equal to 18. Okay, so carry 1, bring down 8. So F is 15 plus B is 11. So 26 plus 1 is 27. So 27 is 1B in hexadecimal. So 1 and then B. And then that right here. So A plus A is 20 plus 1 is 21. So 21, but it's 15 in hexadecimal. So carry 1, bring down 5. A plus B is again 15 plus 11, 26 plus 1 is 22. So 22 in decimal, but it's 16 in hexadecimal. So carry 1, bring down 6. And then bring down that carry. So the result of this one is 165 that B8. Okay. So of course, be the base of 16. So are we clear with hexadecimal addition? Okay, very good. All right, so since we don't have enough time anymore, so we'll just continue the rest on the second meeting or the part 2. Okay, so goodbye for now and see you guys later. Okay, so good morning again. Okay, so let me just check if you guys are already in front of your computer. So just give me a thumbs up. Okay, so most of you are already here. So I guess we can now continue this one. So again, with this sample problems, we will not, or I will not give this one as your activity. So this will serve as your practice activity. Okay. So yeah, again, as usual, if you want to practice, so you can do that one. And then if you want me to check your answers, so you can send to me your solution. Okay. Then I'll be the one who's going to check if it's correct or no. Okay, so let's now move on to the multiplication of binary numbers. So I would say that this is the easiest part of binary addition. Okay, so as you guys can see right here, everything looks normal. Okay, so if you're going to multiply this one on this operand 1, so it's the same on how we do things in, in normal mathematics. Okay, so 0 multiplied to any number will be 0. 1 multiplied to any number will stay the same. So that's why just simply copy that one and then move one space. So you get 1, 0, 1, 1, 1. And then 0 again multiplied to any number is 0. And then 1 again is simply copy everything. Okay, so we have 1, 0, 1, 1, 1. And then in here, you now have to add them. Okay, so after multiplying, so you have to add them using binary addition. So 0 is 0, 1 plus 0 is 1, 1 plus 0 is plus 0 is 1, 1 plus 1 is 10. Okay, so carry 1, bring down 0. Okay, so 1 plus 1 is 10, so carry 1, bring down 0. 1 plus 1 is 11, carry 1, bring down 1. And then 1 plus 0 is 1, so 1, and then bring down 1. Okay, so in here, normal way of multiplying things. And then after that, just apply again binary addition. Okay, for you to be able to get this one. All right, so are we clear with this one so far?
Yes, sir.
Okay, very good. So I guess we don't have a problem with multiplication of binary numbers. So let's have one exercise. So let's get this one. This is number 4 right here. Okay, so 1010 dot 1010. Okay, and then it's 10 dot 11. All right, so in here, well, since we have to, yeah, okay, it's just the same. All right, so in here we have 1 times 0 is of course 1. I mean, it will stay the same. 0, 1, 0, 1, 0. So 0, 1, 0, 1. And then that 0, 1, 0, 1. Okay, and then another 1 right here. Just simply copy everything, but move one step. Okay, so 0, 1, 0, 1, 0, 1, oops, 0, 1, 0, 1. Okay, but in here we now have 0, so same method, just move one step. So we now have here uh 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 1, 2, 3, and then 4. Okay, so let me just move this one a bit right here. And then another one is 1, so just simply copy everything but move one step. So the decimal is now in here. So it's, where are we now? 0, 1, 0, 1, 0, 1, 0, 1. Wait a second, is this correct? Because for the decimals, they are not aligned with each other anymore. Okay, so we'll just verify this one later on. But for now, after this, of course, we have to add everything. Okay, so 0 is still 0, and then 1 plus 0 is 1. And then 0 plus 1 plus 0 is 1. 3 zeros plus 1 is 1. 1 plus 1 is 10, so carry 1, bring down 0. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 is 11, carry 1, bring down 1. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 is 11, carry 1, bring down 1. 1 plus 2 zeros is 1, and then bring down that 1. So in here, the only thing that uh, is quite confusing is the decimal point, since we have 4 decimals right here, but in here we have 2. So if you're going to follow this one, Even me, I forgot where to put the correct placement. Okay, so where do you guys think we need to put our decimal point? Is it right here or somewhere around here?
Parang dyan, sir.
Right here. So we have to count 1, 2, 3, 4, 5, 6. Verify nga natin. Okay. So let's go back with, normal way of multiplying things. Multiplication with decimal. Nakalimutan mag-multiply with decimals. With decimal point. Okay. So in here we have one decimal, but the other one have a 2. So 2 point, yeah. So this is, that one is correct. So you simply have to count how many decimals the first operand have and then the second operand have. So we have 2 decimal points and then 1 decimal point. So 2 plus 1 is 3. So just simply count 3 decimals on that one. But in here we have to count 6 decimal points. So 1, 2, 3, 4, 5, 6. So the answer for this one is 11101 and then 001110. Okay. So are we clear with this one so far? Okay. So never mind my decimal points right here. So that is a correction. Okay. So to avoid confusion, just remove those and then just finalize the decimal point on your final answer. Okay. Do not do what I did in here. Okay, so that's the reason why I'm a little bit confused a while ago. Anyway, so that's it for the multiplication. Okay, so I hope everything is clear with this one already. So more exercises. Okay. Ah, my bad. So let's answer one of this because you cannot directly multiply c times 7 right away. Okay. So you have to convert this one. Okay, actually you're going to have double conversion. Okay, so first conversion is to convert this one into binary. Okay, then after that, do now the math, using multiplication. And then after getting the result, okay, let's say the binary combination, you have to convert that one, going back to, let's say, hexadecimal, or going back to octal, or going back to base 7, and so on and so forth. So let's answer number 4. Let's answer this one. Okay, so in here, we need to do double conversion. So we have to convert this one into binary, this one also into binary. So let's start with the 7. So again, if it's hexadecimals, we have to group them by 4 every 4 bit. So 7 is 0, 1, 1, 1. 4 plus 2 plus 1 is 7. Okay, and then A is 10. So it's 1, 0, 1, 0. 1, 0, 1, 0. Okay, 8 plus 2 is 10. And then 1 is just simply 1. Okay, or 0, 0, 0, 1. Okay, but then again, we can actually remove that one. Okay, so we'll not remove that one for now. Okay, we'll just finalize the answer later on. So let's include the 3 zeros for this one. So the second operand, so we have to convert this one. Oops, yeah, okay. So we have to convert this one also into binary. So C is A, B, C is 12. So we need 8 plus 4. So 8 plus 4. So it's 1100. And then that. Okay, and then 9 is 1001. Okay, and then multiply. Okay, so are we clear so far? And the first process on how to multiply this one. So we have to convert this one into binary first. And then after that, you can now perform the multiplication. So if it's 0, everything will be 0. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Same as this one, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And if it's 1, so what? 1, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, and 1, 0, 0, 0. And then another 1. So medyo mahaba-haba. So tiis-tiis lang. 1, 1, 1, 0. And stay focused. Kasi pag nawala kayo, pag may isang mali, mali na lahat. And then 1, 0, 0, 0. Okay, so we're done with the first 4. Let's now move on to the second 4. So still 1. So copy everything. 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 0, 0. Okay, and then 0, 0, 0. So 1, 2, 3. Dito na tayo. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Another 0 right here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then another 1 right here. Just simply copy everything. 1, 1, 1, 1, 0. 0, 1, 0, 1,
Sobra ng 1, sir.
1, 0, 1, 0, 1. Teka lang. 1, 1, 1. My bad. Thank you. Sobra ng 1 dito. So 1, 1, 1, 0, 1, 1, 1, 0 dito. And then 0, 1, 0, 1, 1, 0, 0, 0. Finally, okay, we're done. And then just add everything. So this one is 0, 0, 1, and then 10, carry 1, bring down 0, 1 plus 1 is 100, carry 1, carry 0, bring down 0 right here. 0 plus 2, 1 is 10, carry 1, bring down 0. 1 plus 1 is 10, plus 1 is 11. So carry 1, bring down 1. 1 plus 1 plus 1 is 11, carry 1, bring down 1. 1 plus 1 plus 1 is 11, carry 1, bring down 1. 1 plus 1 plus 1 plus 1 is 100. Carry 1, carry 0, bring down 0. So 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 plus 1 plus 1 is 100. Carry 1, carry 0, bring down 0. 1 plus 1 is 10. And 1 plus 1 is 10 again. And 1 plus 1 is 10. 1 plus 1 is 10. Bring down 1. 0, 0. Finally, tapos then. And then for this one, so just count how many decimals you have. So 4 plus 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. So the decimal point will be right here. And after that, you have to convert this one now again, going back to hexadecimal. Okay, because that is the number system in here. So in here we have 4, and then we have 12, where in hexadecimal 12 is A, B, C. Yeah, C. And then that right here. And then by 4, so 1, 2, 3, 4. So up to this point, it's 1. And then another one is a 0. 1, 2, 3, 4. And then 1, 0, 0. So you can have additional 1 right here just to make this one, formal by 4-bit. So this one is 1. So the final answer is 101.C4 base 16. 101.C4 base 16. Okay? So were you guys able to follow? So I know that masakit sa mata. Ang dami oh. Tapos ang pangit pa ng handwritten. Well, anyway, but yeah, that's the process that you guys need to do when it comes to this hexadecimal multiplication. So yeah, it's easy, but It's quite long. Okay, and then once one of your answer is already incorrect, and everything is already incorrect, of course. So just be careful with this one. Okay. Sir, di lang gets yung pag-convert to binary. Okay. So when it comes to converting that one to binary, so just go back right here. Where is that one? Here, hexadecimal to binary. Okay. So just convert this, every character actually, it's super simple. 5 is this 10101. So the value of this 1 is 5. The value of this F is 1111. The value of A is 1010. 1 is 0001. Okay. So just go back with this topic again, Mr. Jan Vincent, for you to be able to get how to convert hexadecimal to binary. Okay. Any other concerns so far? Anyone? Was I able to answer your question, Mr. Jan Vincent?
Yes, sir. Thank you po.
Okay. So I will not answer the others anymore since they are super long. Okay. So as long as you know the conversion from octal to binary, n base, 7 base to binary, then you're good to go. Okay. So the last topic is signed binary numbers. So in here, this is super simple. Okay, you only need to memorize or familiarize 3 steps. So let's proceed with this logic first. So when we say sign binary, okay, so remember that I did mention a while ago. Okay, so it's not in here. So I did mention a while ago that when we say unsigned, unsigned binary, it is simply positive, positive numbers, okay, or positive binary numbers. But when we say sign, so it now has a sign, of course, it's either positive or negative. But mostly when we say sign binary, we're dealing with negative numbers. Okay? And in binary number, binary combination, we cannot say that, this one is negative 001 just to make this one equal to negative 1 in decimal. Okay, there is no way that we can put a negative symbol in there. So the logic behind to make binary number in, let's say, into equal to negative number, okay, is to make the the 8 bit, yeah, the 8 highest bit. So if you want to represent negative 1, so you're going to make it something like this. Okay, so this one, if it's 1, this one represents negative. Okay, and then whatever is the value right here, that is the negative 1 that you are saying. So this one is equal to negative 1 in decimal. So if you want negative 7, so 100, so this one is an indicator of negative. And for 7, it's 0111. Okay, this one is equal to negative 7. Okay, if you want to represent this one into positive, well, of course, you only need this one. Okay, this one is considered positive 1, and then 0111 is equal to positive 7. Okay, so that's the logic behind this positive 9 and negative 9. So positive 9, just make that 1 0, or just simply write 1001. Okay, and then for negative 9, just make that 1 1. Okay, but that is just the concept. Okay, this is not the one that we are going to use. Okay, in a computer, okay, he's actually using the logic 2's complement. Okay, so if in human, this is what we're going to use, but in computer we have to use this one because this is what our computer is doing. Okay, so if you guys are going to compare this one, this negative 9 is not the same with this negative 9 anymore. Okay, it is actually quite far already. Okay, so in here it's 100, but in here it's 1111. It's here in here it's 1001, but in here it's 0111. Okay, so how are we going to get this kind of result? This is -9, -13, and then -6. So here are the steps that you guys need to follow. So represent -9 in signed binary number with 8 bits. Okay, so the first step is write the +9 in 8-bit binary. So the normal way of doing things. So just represent this one into +9. So the first step is 0000 1001. So this is the +9 representation. Okay. And then after that, you have to complement each bit. So when you see complement, 1 will become 0 and then 0 will become 1. Okay. So parang magpapalit lang. Okay. So in here, 1 became 0, 0 became 1. Okay. So this is now the second step. And then the third step is add 1. Okay, so binary addition. Okay, so +1. So 0 plus 1 is 1, and then the rest remains the same. So this is now your final answer when it comes to sign binary of -9. So if you are going to take a look on this one is the same with what we have in here. Okay, so were you guys able to get this one so far? So just familiarize those 3 steps. So the first one is write that one into a normal way, +9, then complement, and then add 1, and then that's now the sign binary number of that specific number. Okay, so let's have one example. Let's have the uh, let's have 69, -69. Okay, so we want to get the -69 in by sign binary number. So first step, we have to represent that one using +69. Okay, so in here, 69 is 3264. So it's 0, 0, 0, 1, 0, and then we need 5. So it's 0, 1, 0, 1. Okay, so please double check. So this one is 0, 1, 2, 4, 8, and then 16, and then 32. My bad. This one should be is the one that is 1. Okay, because it's still 32 and this one is already 64. So 64 plus 5 is 69. So are we clear so far with the first step? Okay, so this is the positive representation of the binary +69. And then second step, okay, let's complement each bit. Ayaw. Well, anyway, so, uy, bakit hindi na ako makapag-type? Okay, let's find a remedy. So in here, the complement of this one is 1, 0, 1, 1, 1, 0, 1, 0. And let me just align this one. There you go. Okay. Then after that, third step is you have to add 1. Okay. So in here, we have positive. Nag-tab ka, ayaw niya na. Positive 1. Okay. So in here, it's 1, 0, 1, 1, 1, 0, 1, 1. So 0 plus 1 is 1. Okay. There you go. Okay, so this is now the representation of -69. 1011 1011.
Sir,
Yes.
sir, 111 po ata lahat yung dun sa dulo.
Okay, baka na-confuse ka. Okay, the only one that we need to add is this part, second step and then third step. Okay, yan lang sila. Hindi kasama to. Okay? So, ito
Okay.
yung una, and then ito na yung complemented. Okay, complemented results. So, 0 became 1, 1 became 0. Okay? So, the same with what we have in here. So, hindi kasama to, okay? So, ito lang yung original, and then the one that we need to add is the second and third step only. Okay, so that's why 0 plus 1 is 1, and then the rest remains the same. Okay? Sir, paano ulit na-convert yung 69 to binary? Ayun, as long as you know the sequence, so remember that, let's say in 4-bit, each one of them has a value, specific value. So this one is 1, this one is 2, this one is 4, this one is 8. So if we have more binary number, let's say another 0, 0, 0, 0 right here, this one now is 16. So it just keeps on doubling, okay? So 16, 32, 64, 128. So in this example, we need 69. So we have to activate the 64 right here. So 0, 1. So we don't need 32, we don't need 16 because it will exceed the 69. So it's 0, 0. And then we don't need 8 because 64 plus 8 is 72. So it's still 0. 64 plus 4 is, yes, 68. So we need that one. So we don't need 2, and then we need 1. So 64 plus 4 plus 1 is equal to 69. Okay. So that's how we've got this 0, 1, 0, 0, 0, 1, 0, 1. Okay. So I hope I was able to answer your question, Mr. Reginald. Okay. So any other concerns so far? Okay, so if none, just give me a thumbs up if everything is already clear. Okay, very good. So we're actually done already. So in here, these are just few examples. So uh, positive 6 and then positive 13. So I guess we don't have a problem with this one. Just convert this one into binary. And then the same with this one, convert this one into binary. And then you will have this one just by adding this one using binary addition. But in here, so we now have a negative, so you have to apply 2's complement on this one. Okay, after applying 2's complement, you will get this one as a result, and then you can now perform negative, okay, or subtraction. So positive 6 minus 13, you'll get negative 7. Okay, so the same with this one and this one. All right. And then more exercises for you guys. So the same concept with what we have in here. So if you want to practice more, and then let's say if you're not sure with your answer, so again, you can send me a message with your solutions. Okay. So again, on why we're talking about, or on why we are studying about number system. So this is the reason. Okay. So we have this ASCII code. Okay. So as we click, or as I click letter A, my computer or our computer doesn't read it as a letter A directly. Okay. So it could be a hexadecimal combination. It could be a decimal combination, could be octal, it could be binary, and so on and so forth. Okay, so the ASCII code, or American Standard Code for Information Interchange, has 128 characters, or 7 bits required. So this one contains a non-printing, okay, and then printing characters. So printing characters is any character that we can type and then we are seeing a result, okay, uh, on our monitor. And then non-printing is, let's see, I'm clicking my alt button right now. I'm clicking my control button, my shift, my caps lock, my tab, escape. So we are not seeing anything. So those are the non-printing characters. Okay, but of course they also have their own ASCII code in here. Okay, so here are the some combinations or some that we can also do. Okay, like null, start, start of text, end of text, and then they have their own decimal and then hexadecimal and then octal combinations. And then we now have here the special characters. Okay, special characters, the numbers, okay, and then the capital letters, small letters, and parang naulit lang. Okay, since this one is just an exercise. So, parang eto na yung lahat. Okay, a total of 127 characters from 0 to 127. Okay, so ito na yung mga non-printing characters natin. Okay? So backspace, ito lang yung mga familiar. But the others, so they have their own namings. But yeah, control, alt, so they are under right here. Okay, so just a different name. So are we clear so far with the ASCII code? Okay. All right. So yeah, if you want to do this exercise, so well, feel free to do this one if you want, but this is not required. Okay. And let's talk about binary storage and registers. So register is a group of binary cells that are responsible for storing and holding the binary information. Okay, so it is basically where our characters that we are clicking right here is being registered to. Okay, and then register transfer operation is transferring binary operation from one set of registers to another set of registers. Okay, so after registering onto the first cell, it will be transformed or it will be converted into this cell, and then another conversion, and then it will be displayed to our monitor. So we have a lot of conversions happening in our computers. So, hindi lang siya directly na one conversion, let's say from hexadecimal into a letter. Sometimes it needs two conversion or three conversion. Okay? And then the one that is doing that one is the digital logic circuits. This is the one processing the binary information stored in the registers. So this is one example. If I click JOHN, so it will be passed into our first registers, okay, or onto the control system. So they will be grouped by 8 cell. So ito na yung dito lang tayo kasi sobra na to eh. This is the letter J, O, H, and then N. Okay, and then there's going to be another conversion. So this 8 cell will be converted into binary. So this is now the representation of J in binary, representation of O in binary, H in binary, and in binary. So as you guys can see, we have like 3 register. Okay, we have the memory register, we have the processor register, and then we have the input register right here. Okay, so we have 2 or 3, so that depends on what we are doing on our computer. Okay, so this is just a simple typing a name of JOHN, and then it already did 3 process all in all with our memory system. Okay, and then here's a more realistic example of this one. So if you want to add this operand 1 and then operand 2, so basically we type 225. What did we use in here? So addition. Okay, so we type 225 plus 66. So of course it will be converted first into binary. Okay, and then this is now the operand, okay, or operation. Okay, so this one will go first right here, and then it will be added by this digital logic circuits for binary addition, and then it will now fetch the second operand, which is the R2, Okay, and then after that, it will be resulted as a binary, and then this 291 will be displayed on our memory unit. Okay, and then it will be displayed as 291 in our monitor. Okay, so that's basically what's happening with our uh, processor, or how our uh, memory process things in our computer. Okay, so yeah, that's already it for the module 4. So I hope you guys did learn a lot of things, especially on how our computer reads the data. So do you guys have a question so far? Questions or clarification? Or if none, then just give me a thumbs up, and then you guys may not go, since we don't have enough time anymore. Okay. So goodbye and thank you guys for coming. Okay. So we will not meet on the module 5 and 6 anymore. So I'll give the rest of our meetings as your free time to finish the quizzes and then the laboratories. Okay.
Goodbye and thank you, sir.
Goodbye and thank you too.
Ilan?
Sir, thank you.
Oh,
Goodbye and thank you.